Now the way linear equations can be written, slope-intercept form is worthy. This equation is helpful when you know the slope and y-intercept y equals mx plus b, where m is the slope and b is the y-intercept. X and y variables, they will become. Slope is the change in y divided by the change in x, so just remember rise over run. Let's try a simple equation. Graph y equals 1/2 x minus 2. Y-intercept is -2, slope is 1/2 of 1 over 2. Now that you know the slope and intercept, draw a straight line through both the points you plotted. And now you're finished. You've got a linear equation. Slope intercept form of equation. To linearly draw a line straight when you're graphing y equals mx plus b. Slope intercept form of equation. To linearly draw a line straight when you're graphing y equals mx plus.
Well, welcome back, Algebra 1 students. Here we are again with graphing linear equations, this time in slope-intercept form. So you saw the second half of that linear equations song video, and it was talking about the slope-intercept form, looking at y equals mx plus b. That's a famous equation. We know that, and we'll know that for many, many years to come through math. And it's just an equation that we can identify the slope and the intercept from, the m and the b. So that's what we're going to be doing. We're going to be finding the slope of a line. We're going to be using slope-intercept form of linear equations, and we'll be doing some real-life problems as well. So let's look at our cartoon for the day. Sorry, mister, but this is what we do to cattle rustlers in these parts. Just roped them to a tree and torturing with tickling. All right, let's go on to looking at the core concept in just really the main vocabulary word in this one here, slope. Understanding really what slope is. Slope really is the steepness of a line. It's just describing the steepness of the line there, and so that's what we're looking at when we're talking about slope. And really, it's just the change, it's the rate of change as well. It's the rate of change between any 2 points on that line, and that would measure the steepness of the line. And so to find the slope of a line, you can find the ratio of the change in the y. That would be the vertical change going this direction. As you can see it in red here, it's changing in the y would be changing by 3. It's moving up by 3 from those 2 points. And then the change in the x, which would be the horizontal change, you can see that illustrated there by 2. Core concept also talks about a couple of different ways that we can identify the slope of a line. Slope can be thought of as rise over run, so that's what the video mentioned, that. Rise over run, it's the same idea here, the rise and the run. So the rise would be the vertical change and the run's the horizontal change. So there's always just 2 different types of changes. A change in the y, which is a vertical change going up or down, and then the change in the x, which is horizontal change going left or right. Now, depending on the direction that you do go, that could make it either a positive direction or a negative direction. So you can see both of these are positive numbers, 2 and 3. That's because 2 is going to the right, that's a positive direction. 3 is going up, that's also a positive direction. So our slope is a 3 over 2. Okay, the change over in y, a change in x. So 3/2 or 3 over 2 is the slope of that line. Now we typically would leave the slope as an improper fraction, and we would not make that a mixed number, because we always want to think of it just in terms of a fraction, not a mixed number. Another way we can identify the slope of a line is doing this. If we knew those 2 points, so if we just knew the 2 ordered pairs, maybe we didn't see the graph at all. We don't have a picture of it, but we do have the knowledge of these 2 points here in ordered pair form. What we can do to find the slope of a line that goes through those 2 points is we can subtract the y's on top of subtracting the x's. This one says y2 minus y1 over x2 minus x1. You could go the other way as well. You could do y1 minus y2, x1 minus x2. The main point there would be if you start with this point, then you got to start with this point for x. You have to start with this point for y as well. So that's why these should match up. These are the second points from the second ordered pair here. This is from the first ordered pair on this one. All right, let's move on. So hopefully that was information that you want to take with you here, and slope is a concept that you need to remember for a long time to come to understand what slope is and just how to find the slope of a line. Okay, another core concept or concept summary about slope is just the different types of slope that we do see. So sometimes we'll see a positive slope, negative slope, slope of zero, or an undefined slope. So a positive slope is always going to rise from left to right. And so you want to think about where the arrow is. The right side of this is really what you want to see. Where's your arrow on the right side? And so if that one is pointing up, that's a positive direction. So it's going up, it's a positive slope. On this one's going down from left to right, falls from left to right. So again, if you look at the right side, where's the arrow ending up? And that one's in the negative direction, it's going down. This one, it's flat across, it's a horizontal line. So a slope of zero is always a horizontal line. So just think about, any flat surface that you could stand on, the ground, a table or anything that's got a flat surface like that, a horizontal surface, has zero as a slope. And the reason why it has zero is because there is no rise. Rise would be zero. The run could be some number, but zero over any number is going to be zero. That's why it's a slope of zero. This one you can see is a vertical line. It's an undefined slope. And you can see this one doesn't have any run. So it's not going left or right at all. So there's no run on this one, which would be the bottom number of your slope. Any number over zero is always an undefined fraction. So we could think about this as the guy here, he's fallen off the cliff. He slips off. So there's no slope here. There is no slope. When he can't stand on this one because he's just going to fall right off. So no slope on that one. So these are different types of the slopes that we will come across. All right, let's take a look at page 83 at the top there with extra practice 1 through 3. It says describe the slope of the line and then find the slope. So we're going to describe it either as a positive, negative, zero, slope of zero, or an undefined slope, or no slope, we could say. So this one, number 1, you can see it's a vertical line. So if you think about, if you were to place your little stick figure, is he going to be able to stand on the line? If he stands on the line, there is a slope. It's a slope of zero. But if he can't stand on the line, you fall off. There's no slope. So there's no slope on this one, or you could say it's also undefined. So that's your slope for this one. There is no slope number. Number 2, this one is, as you can see, it's going uphill from left to right. So you look on the right side arrow, it's going up. That's a positive slope. So it's going uphill. And so now we take the 2 points that are there. We want to do a rise or a run. So our rise is going to go from, I'll start from the bottom here, go all the way up to the level of where our nether point is. So we're going to rise up to this level where the other point is at, and then we're going to run from there over to that point. And now we just want to count the rise over the run. So our rise, if you count that, 1, 2, 3, 4, 5, 6, 7, 8. So your rise is going to be 8. So we'll put that on the top of the fraction. And then the run, we'll count that one. 1, 2, 3, 4. Our run is 4. And these are both positive directions. You can see I'm going up, that's positive 8, and I'm going to the right, that's positive 4. And so that's going to be a 4 at the bottom of that fraction, which simplifies to 2. So our slope is 2. The slope of this, the steepness of the line here is described by 2. Number 3, you can see what kind of slope is this. It's going downhill from left to right. Its arrow on this side is pointing in the negative direction, so it is a negative slope. And then for rise over run, we do the rise here. Again, I'm going to go from one point to the other point. So I'm going to go from the point on my left, which means I'm going to go down here to that level of this point. That's my rise. And then I'm going to run from there over to that point, and that would be my run here. And so the rise then, as we count this, we're going to count going in the negative direction. So it's going to be a negative number. So this is going to be 1, 2, 3, 4, 5. That's a negative 5. So since we counted down. And so it's going to be on the top, negative 5 on the top. And then we're going to count 1, 2, 3, 4, 5 this way. That's in the positive direction, so positive 5 for the run. And so 5's at the bottom, and then we just simplify our fraction if we can. If you can't simplify the fraction, then that's your slope. But negative 5 over 5, we can simplify that to a negative 1. So this steepness of this line is described by negative 1. All right, let's move on to our next part. Okay, so right below those three, we see 4 and 5. It says here that the points represented by the table line lie on a line. So all these points lie on a line that we would graph, a single straight line. Find the slope of the line. And so in this case, we want to think about, instead of doing rise over run, because we can't see the actual line on the grid, on the coordinate plane, we want to think about the change in on the y over the change in the x. So write down change in y over change in x. So our change in our y here, as you can see, what's the change from negative 2 to negative 2? There is no change. It's just 0. There is no change there, and continues. There's no change at all. And so your change in y would be 0. There is no change. The change in x, though, you can see from 1 to 2, that changes by 1. And the same thing would happen from 2 to 3 is 1. From 3 to 4 is also 1. So our change in x would be 1. And so this would be 0 over 1. Anytime your numerator is 0, your fraction is 0. If the 0 was at the bottom, then that's an undefined fraction. But the numerator being 0 means we have 0 as a slope. So that would be our answer. Slope is equal to 0. For number 5 on this one, you can see that the change in y here from 11 to 3 is we're going in the negative direction. We're going down by 8. And so you're subtracting 8. Subtract 8 from 11, you get 3. Now, from 3 to negative 5, we also subtract 8 again. From negative 5 to negative 13, that's another subtracting 8. So your change in y is going to be a negative 8. So that's the top number. The change in x from negative 3 to negative 1, you're actually adding 2 on that one. And then from negative 1 to positive 1, you add 2 again to get to that number. From 1 to 3, you'll add 2 again. So the change in x here would be a positive 2. And you can see how the change is a constant rate of change on both x and y. That tells you it's a linear function when you have a constant rate of change for both x and y. So 2 is at the bottom of the fraction for the change in x. And now we just simplify this. This is going to be a negative 4. So our slope for this one will be negative 4. Okay, so now let's take a look at actually the equation of a line in the slope-intercept form. So we saw in the last lesson the standard form of equation. Now we're looking at slope-intercept form equation, which is the y equals mx plus b equation. That's something that's very familiar, and it should be also familiar to you from the past, but it'll continue to be familiar as all linear equations will be in this kind of form, y equals mx plus b. It is the graphable form, the best graphable form for the equation of a line, because we can identify two things. We can identify the slope, which is m, and the y-intercept, which is the b. The x and the y here will just be those letters. Those will be letters, but your numbers here will be m and b. And so what we'll see there is we'll see whatever the b is, that's going to be our y-intercept where it crosses the y-axis. That's going to be our starting point. We would start there and then use the slope as kind of a map with a rise over run to find the next point on the line. And then we just draw our straight line between those 2 points. Right here, a linear equation written in this form here, where basically your slope is 0, 0x plus b, is the same thing as saying y equals b, which is a constant function. And a constant function is just the graph of a horizontal line. We saw those just a minute ago. So horizontal lines that have 0 slope, right, just like the x-axis here would be, that's also considered a function because it passes the vertical line test, and so we can call that a constant function, where it's y equal to a number. Alright, so with still the extra practice here, 6 through 8 says find the slope and y-intercept of the graph of the linear equation. So now these are in equation form, and we still are trying to find the slope and the y-intercept. So you can find the slope and the y-intercept from the graph of a line, just the picture. You can find it from a table of values with the change in y over the change in x. Or we can see it right here. If we can make sure it's in slope-intercept form, we can just identify the slope and the y-intercept from the m and the b. But now number 6 here is not in slope-intercept form, 6x plus 4y equals 24. Well, that's in standard form like we saw in the last lesson. Okay, so what we want to do on this one, we're going to want to change that form into slope-intercept form, and I'll show you how to do that in a minute. Number 7, you can see y equals negative 3/4 x plus 2. That is y equals mx plus b form. That's slope-intercept form there. This one, y equals 5x, it's still going to be slope-intercept form even though you don't have a b number, but still slope-intercept form because it says y equals. So for number 6, we would want to change this in slope-intercept form just by solving for y. So the first thing to do is move 6x to the other side. We need to subtract 6x from both sides, so it cancels on the left, and then we subtract it from the right side. And so when we do that, well, now on this side we're only going to have the term 4y. So we just have 4y equals. And now we have two terms over here. Let's put the negative 6x first. Now we can't combine those together. They're not like terms. So put the negative 6x first, because we want the x term first, then plus 24. So now to undo this 4 is multiplying y, we want to divide by 4. But we need to divide by 4 over here as well, so each individual term is also going to get divided by 4. The negative 6 divided by 4 and the 24 also will get divided by 4. That keeps the entire equation still balanced. That cancels the 4's here. Now we have y equals by itself. We want to simplify the fraction here. First of all, it's a negative, so we're going to put the negative out in front, and then 6 over 4 can become 3 over 2 just by dividing by 2. And then we're going to put the x just next to it, so we can see, okay, here's our slope number there. And then over here we want to simplify 24 divided by 4, which is just 6 plus 6. So now that we have it in slope-intercept form, we can identify our slope right there is negative 3 over 2. That's the m. So the slope is equal to negative 3 over 2. We can identify the b number right there, plus 6. That's our b, which is the y-intercept. That's where it crosses the y-axis. So if we're going to graph this, we would want to start with putting 6, plotting 6 on the y-axis, and then using this rise over run, okay, the change in the y over the change in x, use that as a rise over run to find the next point. That's what we will do here towards the end. All right, for 7 and 8, actually for 7, go ahead and I want you just to find, since it's like this one now, go ahead and identify the slope and y-intercept. So just pause the video, do that real quick, and then check to see if you got those right. Alright, so hopefully you paused it, you wrote down what the slope and the y-intercept should be from number 7. So right there, it should be negative 3/4 for your slope. That's your m. And then the b is right there, 2, so your y-intercept should be 2. So that's what you should have for number 7. Now at number 8, the only thing we're missing here is the b. We have a mx, but where's the b? There is no b, so we could put plus 0. And then we would see, okay, well, our m right there is 5, that's the m, and 0 is the b. So then our slope is 5, but the b, the y-intercept, is 0. So we would actually start plotting 0 on the y-intercept, which is actually at the origin, right there in the center of a coordinate plane. Alright, so let's move on. So that should be pretty easy to do once you know it's in slope-intercept form. Identify m and b, slope and y-intercept. So you got to keep those separate in your mind. You need to know the difference between which one's the slope, which one's the y-intercept. We always start with the y-intercept on the graph when we're going to graph something. Alright, so here's our joke of the day. Why can't a bicycle stand up on its own? Why can't a bicycle stand up on its own? Well, because it's too tired. It's just too tired. Poor bicycle. It's all pooped out. Alright, let's move on. Alright, so if you go back to page 79 in your notes, the very first page of the 3.5 notes, in exploration 2, you'll see these two, A and B. And so just you're going to find the slope, y-intercept of each line. Go ahead and do that. Go ahead and pause the video and write down the slope and y-intercept of each line, and then play it to make sure that you're correct. Okay, so you should have got for A, and you can just see on y equals mx plus b right here, your slope is 2/3, your y-intercept is positive 2. So slope is 2/3, y-intercept is positive 2. If you plot the points, go ahead and do that with me. Go ahead and plot the point there. This is how, if we didn't have the line and we needed to graph it, this is what we would do. We would start with our y-intercept, plot the y-intercept as positive 2, so there's 2 on the y-axis, and then we would use the slope to help us kind of find or give us the directions to find the next point or another point. So your rise would be 2, your run would be 3, so it's always rise over run. So you're going to rise 2 and then run 3, and then you'll put a point right there. There's another point that would be on that line, and then you could draw the line between those 2 points. On B, you should have saw that it's negative 2 for the slope, and the y-intercept is this negative 1. The slope is negative 2, y-intercept negative 1. Let's go ahead and plot the y-intercept. Negative 1, the y-intercept is right here. That's where it crosses the y-axis. Go and plot that point. That would be our starting point to graph this line. If we needed to graph it, we'd start with that point. And then using this slope, now the slope is not a fraction, so we would put like an imaginary 1 underneath it. So negative 2 would be your rise and 1 would be your run. So if you go down negative 2, you can go either down 2, that's negative 2, and then run 1, so you can go right there. Or you could go the opposite. We could say our rise is 2 and negative 1 would be our run. So we can go up 2 and left 1. So either of those points would work, that point or this point, and you can draw your line through it. Alright, so here's number 9, and it's back on our extra practice. So we are at the bottom of 83 here with this problem. As it says, a function f models a relationship in which the dependent variable decreases 6 units. For every 3 units, the independent variable decreases. Okay, so right there, we talked about this before, dependent and independent variables. So you need to remember that the dependent variable, that's the one that it depends on what is the outcome, or it depends on what you put into the function. So that's going to be your output, which is the y, and your independent is the input, what you put in. That way it's independent of the y. That would be x. So independent is always the x coordinate, the dependent one is always the y. It says the value of the function at 0 is 4. It wants us to graph the function here on this coordinate plane and identify 3 things: slope, y-intercept, and also the x-intercept of the graph. So first of all, let's look at slope, because we're going to need to know what the slope is to be able to graph this on this graph here. So it does say here, so identifying slope now, it says that it decreases 6 units for every 3 units on the independent. So the dependent one, so the change in y is going to decrease 6, and the change in x is going to decrease here 3. So your change in y is always in the numerator, and the change in x is the denominator. So change in y is negative 6, change in x is negative 3. And so that means our slope, if we were to simplify this, negative over negative is positive, 6 divided by 3 would be 2, so our slope is 2. The y-intercept, well, it says it right here that the value of the function at 0 is 4. So I do a little just table of values. The value of the function at 0 is 4. So that would be a 0, 4 ordered pair. X would be 0 and y would be 4. And so that case, that would be our y-intercept. The y-intercept would be 4. So now we have enough information to be able to graph this. We'd start with our 4, start with that starting point there. So 4 on the graph is going to be right up here. And then you can do a 2 slope, or you could do this as well. We can go down 6 and left 3. That's a negative direction. I can go down 6, that takes me down to here, and then left 3 puts me right over here. And so I can draw another point right in that spot. And now that I have 2 points, I can then draw my line. So I can draw that line right through there. And then we can see, okay, now we can identify the last thing here. What's the x-intercept? Where does it cross the x-axis? And you can see that's right there at negative 2. So the x-intercept, where it crosses the x-axis, is negative 2. Alright, we're going to come and I'm going to give you some practice. I want you to graph a few more of these equations on your own here, so we'll do a few of those here. So on the bottom of page 82, you'll see a little section that says Notes, And you're just going to put these three problems down. You can go and just write these three problems there, 9, 10, and 11. You can number them just the way they are numbered here. That's fine. So what we're going to do here is we're going to look at how now this one is in slope-intercept form, but those are both in standard form. So what we're going to need to do is change those into slope-intercept. I'm going to have you do that there. So for 9, we're already in slope-intercept form. So I want you to pause the video and change both 10 and 11 into the slope-intercept form, the y equals mx plus b, just like 9 is. So go ahead and pause the video and do that for number 10 and 11, where it will say y equals. And then go ahead and play it and see if you did it correctly. Okay, so you should have paused it, and here's what we'll see for number 10. I'm going to write it again over here. And first thing we would need to do to get the y by itself is we need to move that 3x to the other side, undo it by subtracting 3x. Once we do that, we do have y just now on the left side by itself. We want to put the x term first, negative 3x, and then minus 3. And then for number 11, I'll put that one down here. We got x plus 2y is equal to 6. This one, the x term's got to move over first, so we got to subtract x from both sides. And so when we do that, the x's cancel there, and then we got 2y on the left side, and it's equal to, put the x term first, negative x, then plus 6, because we always don't want it in the x, then the mx part, then the b part. That's why x has got to go first. And now we just need to divide everything here by 2. So you should have done that. Now, when you're dividing this by 2, you don't see a number in front of x, so you can put a 1. Actually, that would be a good idea. So you can see 1 over 2 now, and then 6 gets divided by 2. So these 2's cancel. So this is now going to have y by itself, and now you have a negative 1/2 as a fraction. Negative 1/2, put the x next to it, and then 6 divided by 2 is 3, so plus 3 in the back. So that's going to be our two forms there. So those are in y equals mx plus b forms. Now for number 9, what you should have now underneath number 9 is just going to be a graph. So those two we're just going to want to change into this form. That way we can graph them. Let's go ahead and just actually graph number 9. So you draw a coordinate plane. And we're going to need to put some points on this. So we need to go at least, I'd say, maybe 5 each way, something like that. So 1, 2, 3, 4, 5. And you can see that's going to be our y-axis there. We go 1, 2, 3, 4, 5, and that's going to be our x-axis here. And we can keep going this direction, 1, 2, about the same distance. Try to match, going about the same distance there. And then again, 5 this way, 1, 2, 3, 4, and 5. Put arrows on the ends there as our arrows. So our starting point is negative 4. That's our y-intercept. So we need to identify slope is 4, y-intercept is negative 4. So we need to plot negative 4 on the y-axis. Here's our y-axis. 0 is here, negative 4 is going to go down 1, 2, 3, 4. So that's our y-intercept right there. The slope is 4. We want to put like an imaginary 1 underneath it. So your rise is 4, and then your run is 1. And they're both positive, so we can go up 4, 1, 2, 3, 4, back to the origin there, run 1, and we can plot another point right there. We could do it again if we wanted to. We can go up 4 and run 1 again. We'd find a point on the line as well. But then you can just draw your line. If you have a straight edge, use a straight edge, like a ruler or a compass, or I should say a protractor, or a just even like some kind of card, gift card or something like that would work. So that's what your line should look like for that one. Alright, so that's all I wanted you to do for right there on page 82. Remember when you were doing this on our page, bottom of page 82. And we're going to do just a few more. We're going to go back a page now back to the beginning again. So that's back to 79. At the bottom of 79, I'm going to have you do that exploration there. Alright, so this is the exploration number 2, right back at page 79. So you're going to fill in the chart here. Now when A is kind of filled in already for you, So you want to fill that one in. I mean, it's already filled in for you. So this one you want to graph here on your first one. So graph A, you'll graph that one. But then you're going to fill in this one. In the description of the graph, these are all linear functions. They're all y equals mx plus b. So the description of the graph should be the same all the way down. It's a line for all of those. But then you're just going to put the slope here. And what I would do is I'd put the slope there, but then make it a fraction so you can see what rise over run is. And then the y-intercept here, and then go ahead and graph it again on the next one. So A, B, C, and D, you have it on a couple pages. I think the first two, you're graphing on 79, the bottom there. The next two, C and D, you're going to graph on the top of 80. All right, so go ahead and pause the video while you're doing that. Now, I did put this as well, sorry. Right there above slope, I said directions to the next point, y-intercept start point. So you always want to start with this number here when you're graphing. You're going to start with 3 on the graph, like right there. There's your starting point. Then use this as the directions to find the next point or another point on the graph. So you have 2 points, and then connect the dots with your straight edge. All right, so go ahead and do that for A through D, and then play it so that you can see if you got these lines correct. All right, so if you've got all these now lines down here on your graphs, everything's filled in. So for A, let's go ahead and just look at this one. We're going to graph A here. For the actual slope, you might want to do this. You might want to put the negative with one of those two numbers. So I'm just going to put it with the top number and say my rise is going to be a -2, runs +3. So I start with 3. Like I said before, it's going to start right there. I'll put a point on that line right there. And then you're going to find the next point with going down 2 and then right 3. So down 2, right 3, there's your next point. Your line should look like this, going downhill. It's a negative slope. So right there, you know it's a negative slope. Right there, you know it's going to be going downhill. This next one, B, is going to be going uphill because it is a positive slope. So you'd write the line, that is, the description of the graph is a line. Your slope is 2, but you might want to make that into a fraction of 2 over 1. So you can see the rise is 2, the run is 1. Your y-intercept is -2, so it's going to start at -2 on the y-axis. It's right down here, and then you can rise 2 and run 1 to find the next point, and then you're going to draw your line through those 2 points, and it should be going uphill. Letter C is also going to be a line, so these are all going to be lines, of course. Your slope is, even though we can't see the 1 in front of x, we assume it is a 1. -1 is our slope number. So you can make that into a fraction by just putting that over 1. -1 over 1 is rise over run. And then your +1 there would be your y-intercept. So you're going to start with that point, 1 on the y-axis. Then your slope's going to take you down 1 and then right 1. There's your next point. You'll draw your line through those two. And it's going downhill. As you can see, it's a negative slope, so it is going downhill. And our last one here, letter D, it's going to be going uphill. It's a positive slope. So that's right down the line. Our slope number, even though we can't see it, is 1. We assume there's a 1 in front of x. So that's 1, and you can just make that 1 over 1 for rise over run. And then your -4 there is your y-intercept. So you start with -4. It's going to go down to -4 right there below the x-axis. And then it's going to be rise 1, run 1. And so there's 2 points, and you're going to draw your line through those 2 points, and you can see it's going uphill. All right, so you'll get more and more practice drawing these straight lines with slope-intercept form, or even drawing them with standard form. If you have a standard form equation, it is helpful to maybe just solve for y, get it into the slope-intercept form, because that is the best graphing form for these. All right, so that concludes our lesson on 3.5, and I'll see you again on the next one.